Hello students, this is Dr. S. Prabhakaran, Assistant Professor, Department of Networking and Communication. So this is a continuation video from the last what we have discussed three important interview questions. In the last video we have discussed about some interview questions on array, and this particular session we will be discussing some interview questions on some basic features in C++. Now we will just unreveal the mysteries behind multiple inheritance in C++. For that we have a simple program which showcases the constructor call in the derived class. Now we move into the question straightforward. So the first question, so this is what is the output for the below program. Now first we need to understand, just I'm giving an overview of the program. So in this program we have a base class, it's called as base A, and another base class base B. Now we have a derived class called derived that publicly inherits from both base A and base B, and the keyword focus is used on understanding how constructor are called when an object of a derived class is created. Now first understand what are the classes that is involved. As I already said that if we have base A, okay, so base A with a constructor that prints base A constructor, and base B have a constructor that prints base B constructor, it's called, and the derived inherits from both base A and base B. So when it comes to the call sequence, okay, the sequence of the constructor call when an object of the derived is created. Now when the derived object is initiated, both base A and base B constructor are called before the derived constructor. And coming to the main, okay, so in the main we have created an object D of the derived class. So the moment we create D, we will witness the sequence of the constructor call. Now we will just have a look at executing this particular program and see what is the output that we are getting. See, as you can see, base A and base B constructor are invoked first, followed by the derived constructor. So when coming to the benefits of multiple inheritance, so multiple inheritance allows a class to inherit from one or more base class. So this is one of the key finding that you grasp from this particular program. And also it enables the code reuse and promotes the modular design by allowing a class to inherit functionality from its different sources. So finally we conclude that, so this we have demystified the constructor called in the derived class with multiple inheritance concept. Okay, and next program is also on multiple inheritance. Before that we will just go into the thing. So here I have given a code snippet. From that you are going to identify what is the error in this particular code snippet. So before compiling and executing this thing, we will just go through what is this particular code is about and how all these things are done. Now here we are going to dwell into the intriguing world of multiple inheritance concept. Okay, so here we have a program that unravels the complexity of the different data members ambiguity in the derived class. So now we will give an overview of this particular program. When it comes to the classes, that is two base classes, that is base 1 and base 2. We have a derived class called child. So child that publicly inherits from both base 1 and base 2. This is one of the important thing that we need to understand. And the focus is on understanding how to access and resolve the ambiguity that were the conflicting data members in the base classes. Now coming to the explanation of the classes. Now first, base 1 as the character data member. So base 1 as the character data member, and base 2 as integer data member. So child inherits from both base 1 as well as base 2. But here you can see the data member ambiguity. The ambiguity is what? When we derive a class that is inherited from a multiple base classes, and those base classes have data member within the same name, we face data member ambiguity. And in our case, see, both base 1 and base 2 have a data member named called data, right? So accessing the data member in the derived class. So how we can access the conflicting data member in the derived class? So we will use the thing called scope resolution operator. So this is called a scope resolution operator to specify which base class data member that we want to access. Now we'll just move into the main code, okay, the main function. So in the main function, we just create an object D of the class of the child class, and then we call the show function, okay, of the child that prints the value of the base 2 scope resolution data. Now we will execute this particular program and see what is the output that we are getting. So if we run this particular code, it's literally the garbage value that is printed. Okay, so we can see by using base 2 data, we access the integer data member from base 2 in our derived class. Okay, one important benefit of resolving this data member ambiguity is that we can write clean and understandable code, and also it ensures that we explicitly specify which data member that we want to access when there are conflict. That's very important thing that we need to understand. So this is another standard example of how we are going to code in our C program. So next we'll move into another program. Yes, for this particular code snippet we are going to identify what is the output. Okay, so before that we need to understand a function, that is the size of operator, right? So this particular function, literally we call it as a diamond problem. Now I'll explain what is this diamond problem later. Now see, very simple. In this program we have a base class base with an integer array, and we have two child classes, that is child 1 and child 2, both publicly inheriting from base. And finally we have something called grandchild class that inherits both from child 1 and child 2. See, here the focus is on understanding how multiple inheritance affects the size of an object, leading to the diamond problem. So now we will go into the explanation of the code in detail. Now first, base has an integer array as its data member. So child 1 and child 2 both inherit publicly from base, and grandchild inherit from both child 1 and child 2, forming a diamond shape hierarchy. I said, right, diamond problem. Now what is the diamond problem? Diamond problem arises in C++ when the class inherits from two classes that shares a common base class. In our case, the grandchild inherits from both child 1 and child 2, which individually inherits from the base. Now we will see the size of operator impact. Now the size of operator we use to determine the size of object of the grandchild class. Now understanding the size is very crucial in recognizing the impact of multiple inheritance on the memory usage. Now coming to the main function. So inside the main function we create an object of the grandchild class, and then we print the size of the grandchild object using the size of function. Now we will see, running this code snippet, what is the output that we get. Okay, so 40. So 40 is the size of the grandchild. Okay, so literally if we run the program, we observe that the size of the grandchild object is being displayed. So the important thing is, when it comes to the diamond problem, that can leads to ambiguities and unexpected behavior in C++ program, particularly when dealing with virtual functions as well as the shared data members. Okay, so thank you.